Hello. Sicilian, right? I'd like to make a purchase. One outside of your typical protocols. Yes, I understand the additional cost this will incur, and the risk your company is taking fulfilling such an unusual request. But I'd like to remind you that you will be compensated fairly. And as a sign of gratitude, I'd like to start off the bat by offering you 15% on top. What do you say? We talking business? All right, let's talk. I need one food. A pizza. Cast that to Hawaiian. All right. Now I'll lose the cheese. I need double pineapple. Great. Now cut the sauce. As I understand, my client has no time for pity quarrel. Can you fulfill it or not? So I understand there'll be a cost. Just name it. Is this with or without the delivery special? Thank you. I'll keep that in mind. It's a pleasure doing business. I look forward to seeing your associates shortly.
Hello, hello. You guys should be able to hear and see me now. Yeah, sure, hopefully, maybe. Let me know. Today we'll be doing similar content to last tutorial, but it'll be a bit different. Try to make it a bit more clear and understandable from feedback from last time. And I'll be going into a little bit of quiz review topics. Not a lot. Most of the quiz review was done in the 2:30 to 4 session that I did, and that will be recorded and posted. But I'll be doing a little bit of quiz content now as well. Most of it though will be on that's classes, abstract classes, interfaces, that kind of content. All right, so I'll put up a poll to ask how many of you guys have cloned the GitHub. Launch polling, very nice. That should be launched right now. And then based on that, I'll let you know when to begin. I'll put the link in the chat for you guys real quick. Let me just get that open. It'll give me a second for that. Tutorial 3, where is it? When will the 2:30 to 4 session be posted? Well, that depends on how fast my internet is. It'll be up by like 6 p.m. today for sure. There's the link for the GitHub. Hopefully you guys can get that cloned. I'll show you guys the procedure briefly over on my computer. I will be recommending that you go with IntelliJ for this session because I will be using features that do not exist in Eclipse, but Eclipse will work as well on like a basic level. So let me transition over to show you my screen. Where is Zoom? Oh no, not OBS, not Zoom. Windows plus Facecam, transition. Oh, and today's agenda thing is not actually. All right, so you guys should see my screen now, correct? This is very loud. Music is on. Oh, sorry. Okay, you guys can hear me now without the music, right? Okay, awesome. I'll show you guys how to clone the repository once again. We'll just go into IntelliJ first. You go at the top, VCS, get from version control, paste the link, click clone. I already have it. For you, it'll work. Easy peasy. Now, for Eclipse, we open up Eclipse, wait for it to open, and I'll show you the procedure there as well. Give it a second, it's a tad bit slow. All right, we go up here, we go File, Import. Then here there's a folder called Git, Projects from Git with Smart Import. Clone URI, paste the link, it's already pasted for me. Next, 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 finish, all done. That's how you get it into Eclipse. So if everybody can do that, if anybody has questions, let me know. Otherwise, I'll wait for you guys to get it all cloned. The poll still says 78% of people do not have it, so I'll wait for the the 14 of you who don't have it to change your vote to a yes or ask a question in the chat, and I'll move on to actually doing the content shortly. While I'm waiting, I will say I have this problem. Okay, how to change vote? Okay, I don't know if you can. I don't really use the Zoom voting thing. I'll start another poll. I'll start a second one. Relaunch polling? Yeah. No? Can I like start a poll again? Okay, now you guys should be able to access the poll once again. Oh yeah, I've got a capture.png from my tran. Place it. Can I open file? Oh, that's because you already have it. That's because you already did this last time. You don't have to do anything then, my tran. You're good. It's the same file as last tutorial, so if you went to last tutorial, you already have it. You don't need it. Okay, everybody's got it cloned. Perfect. Well, 93% of people have it cloned. That's pretty good for me. I'll be working in IntelliJ today, but you can follow along in Eclipse. And I'm actually not going to start off with the folder, the Sicilian. I'm actually going to start a new package. And it's just going to be called demo. And you guys don't have to code along with me for this. This is just kind of for me to explain it to you guys. So, I want to create a system of tools. I want to explain like tools in object-oriented programming. I want to have a system where every tool has certain methods like to use it and to to destroy it, to create it, all this stuff. And I need to have different kinds of tools that all share these properties. So I have like a pickaxe, I have like a shovel, I have a flashlight. All of these are tools, and they need to share these properties of a tool. And we're going to go through different ways we can do this. So I think, well, I'll ask you guys, what's your first instinct when you want to create some kind of object in Java? How would you do it? Yeah, I agree. Silence is a great solution. But yeah, a class is also a great solution. So we can create a class here for tool. Let's just do that. Right, and now we have a public class tool. So this public class tool will have certain properties. Let's say it'll have a private int durability, a private string name, and we can add getters and setters for these. So we can generate our getter and setter, and we can do that for this one too. And we have methods, we have fields, we have everything kind of set. We have a normal tool class, but there's a problem because you see every tool we have, the way we use it is different. So if we have like you say public string use, and here we return I used this tool, whatever, or we return null because we don't know. Because think about a tool, right? When we define a tool, we're not defining any specific tool. We're defining the very idea of what it means to be a tool. We're saying every tool has these properties, no matter which tool it is, but it isn't any specific tool. Like this little hand sanitizer thing is a specific tool because it has a specific use and you can actually hold it in your hand like it exists. And it shares certain properties with every other tool. But you can't hold in your hand like the idea of what it means to be a tool. The very essence of a tool is not like a concrete concept. So how do you use the very idea of what a tool could possibly be? Is there any way we could define this maybe in a way that we say, this is the idea of a tool, and then specific tools can have certain properties. For example, I can have here like a lamp, and the lamp extends tool because a lamp is a tool. But yeah, certain properties of it are not defined in lamp. Like I could override here before I get to abstract class, which is what people are suggesting. I could try not having an abstract class. I could say here public string. What is it? Yeah, I'll just do it. Public string use, right? And that is an okay solution, and I can return I light the path, right? And that's the function of a lamp, it lights the path. But this is not super elegant. This will work. This is fine. Like this, a lamp is a tool, and a lamp will override the use of like the use method, right? Is that kind of clear to everybody, or should I explain it differently? All right, I'll take that as all clear. So the use method is written in tool, and then it does null, and then lamp overrides it, and it says, oh, I light the path. So if we create a main, I'll just put the main in, just call it a Nemo, and I call it and I write use, and here I do we'll see that since the tool overrides use, oh wait, no, what's going on here? Could not find or load main class faq.game. Oh, this is because I'm running the wrong thing. I should be running this. There. So you can see that when I create a new tool, it's going to call the use method from tool. And when I call the lamp, it's going to use the use method from the lamp. Does that make sense to everybody, the overriding? So if I show you the graph here, show diagram, class diagrams, so you can see the use method is overridden. So in tool, we have all these methods. It has a use method, and lamp has its own use method, which overrides it. Does that make sense to everyone? If I'm going too slow, also let me know. I'm trying to slow it down from last time, just for the people who weren't able to keep up. So yeah, use is overridden from tool. But there is a problem. And that's not actually a problem in syntax or in compiling or glitches. The problem is in the logic of the program. Because there's no such thing as using the idea of what it means to be a tool. There is such a thing as using a specific tool, like you can use a lamp, you can use a pickaxe, you can use a sword, you can use whatever. But you can't use the idea of what it means to be a tool. So the use method is kind of nonsensical. That's why it returns null. And so in order to make this more logical, we can make tool abstract. And we can make this an abstract method. And we can get rid of the implementation, which returns null. And now, it looks a bit weird. We've got a method here with no body. You have no code in this method. All this is saying is that every tool must have a use. But it's not saying that how to use a tool. It's just saying that to be a tool, it has to have a use. And that's it. Period. Done. It's just tools have uses. By the definition of a tool, it has a use. But how you're going to use the tool depends on the exact tool. So if we go back into main, it's now red. It's not going to let me run the program. If I try to run it, it's going to fail. because it's saying the tools is abstract. Like, tool is abstract. It has no use method. You can't just do that because you can't use. I can't physically hold in my hand the idea of a tool and use it. There's no such thing. So it's nonsense to say use the idea of a tool. It's only okay to say you can use a lamp because it's a tool. Does that make sense to everyone? All right, perfect. So that's the core idea of an abstract class. And now I can demonstrate how it can be useful. Let's say I want to have multiple kinds of tools. Let's say I want to have a lamp. Let's say I also want to have an axe, not an axe, an axe. Yeah. No. All right, I've got an axe and it extends tool. And then for its use, I will say return I chop chop. And now if we look at our graph here, we can say we have an axe and a lamp. And the axe and the lamp provide the use method. And the tool provides all of these methods that are common between tools. Does that make sense to everyone? Okay, perfect. So we're getting along with that just fine. If we run a tools demo here, and we can say tools equals new tool. Oh, I forgot the circle brackets here. Silly me. And now we could say, you know, for tool key in tools. Okay, I run this, and you can see that the sword says, or the lamp says I light the path. The axe says I chop chop, and you know, it depends on how you instantiate them. So here, these are all tools. It's only saying that this is a tool. The reason I can call t.use without it being a specific object is that it's you know, it's a tool. It's using what's common between all these things. But let's suppose that in axe I have another method, and let's call it you know, public. No, not an axe. Axes are pretty simple. Let's put it in a lamp. Let's say a lamp can be turned on, right? So I could say public boolean turn on. And here I can say return true, whatever. Right? It doesn't have to do anything right now, but you get the point of it, right? There's a method now that, if we look at the graph, exists in lamp, but it does not exist in axe. So if I go back into the demo, how do you guys think I could turn on the lamp from this loop? Like, if I only know that the lamp is a tool, how do you think I could turn it on? Can I do it? Can I say t dot? Well, you can see I can't, because it's not a method that exists in tool. But lamp is a tool, so why can't I turn on a tool? Yeah, not all tools are lamps, exactly. So does anybody have any idea of what I could do in order to turn on a tool if it is a lamp? Casting, that's right. So why don't I do that? Why don't I say lamp t.turn on. Perfect. So you see I'm turning on the lamp. I've cast it. Casting means that you're telling the compiler that something is more specific than it actually is. So I've got a rule of thumb for you guys. This is the important line. This is what you want to remember. In Java, what's on the left is the most general thing that you can write. And what's on the right is the most specific thing that you're writing. So you can say object O is equal to new tool. Or I guess lamp. Right? And you can see that the most general thing goes on the left and the most specific thing goes on the right. The compiler only knows the most general thing. The compiler only knows what's on the left. So I can put in comments here. This side is what the compiler knows. And then this side is what you know. Okay, so to cast, what you're doing is you're telling the compiler something that it doesn't know. You're telling the compiler that this is the case when all it knows is this. I saw somebody raise their hand. You're welcome to speak up and ask away. Yeah. It does give an error, actually. If you look at the bottom of the screen, it says exception in main thread, class cast exception, right here. So it is giving an error. You're onto that. Thank you. Yeah, that's a great point, and you're completely right. So where is turn on defined again? If we look at our graph here, turn on is defined in lamp. So tool has all these methods. Lamp has a turn on method that Axe does not have. Does that make sense? Hopefully, right? This graph lets you see which methods are defined in which class. And it's a really useful feature. If you guys want to use this for your assignment, it's just you right-click on a package, and then you click diagrams, show diagram, and you cannot do this in Eclipse. This is an IntelliJ feature. But it's going to be useful for you guys in your assignment as well to be able to do this and see what methods are available where. So that should be clear to you guys now where that's defined. So yes, this side is what the compiler knows, and this side is what you know. Does that make sense to everybody? Left side is the most general. That's what the compiler knows. Right side is the least general. That's what you know. Okay? So here, the compiler knows that it's a tool. So if I split vertically here, get rid of that, So if I see here now, the compiler knows that it's a tool. So the compiler knows this. The compiler doesn't know anything below this. We can pretend that whatever is down here doesn't exist. All the compiler knows is that it's a tool. So it does not know that there's a turn on method because that is below tool. Does that make sense to everyone? Okay, perfect. So when we cast it to lamp, what we're doing is we're telling the compiler, actually compiler, you're stupid. We know that this is going to be a lamp. But of course, the compiler isn't so stupid. So when we try to do this and it's not a lamp, it's going to retort and it's going to say there's a class cast exception. So you can see down here in the big red text, when I try to cast to a lamp, when it's an X, it's going to give us an exception. So does anybody have any idea how we could get around this exception? We can add an if statement. What do you think we'll put in the if statement? That's a great hunch. You're completely right about the if statement, and it's just a method you might, it's something you haven't heard about, maybe yet. So we can say if t instance of lamp. Then we cast this. Now, if we run the code, we don't get an exception. The lamp turns on. And the reason that we do this is we're checking if t is an instance of lamp. So imagine instance of to be an operator which looks at this graph and it sees where on the graph is the object we're looking at. Is the object a lamp or is it anything below lamp? And the reason I say it looks at the graph is if we do t instance of tool, then it's going to check is t either a tool or anything below tool. So when we check if t instance of a lamp, we're checking is it a lamp or is it any class that's below lamp on this chart. Does that make sense to everyone? If not, I'm happy to re-explain. I suppose I'll give a quick re-explanation now. So instance of is a method which checks where on the graph, this graph right here, the class you're checking is located. So here it's checking that if this tool is a lamp or if it's anything below lamp. We don't have anything below lamp right now. But if there was, it would still return true if this was something that was below lamp. Does that make sense to everyone? Okay, great. I'll go slow from there, and I'll say instance of is useful for that. now we can safely call methods of inheritors. I see actually less yeses than before, so maybe I'll just go over it one more time slowly. So instance of is checking if this general object, remember the object on the left is very general, the object on the right is specific. It's checking if the general object on the left is a member of a more specific object. Because remember, objects are like a big tree in Java. It starts at the top with object, and then below that you have all your different kinds of objects which inherit from each other. It's like a huge structure. Maybe I could even show you guys. If I look at OpenJDK 14 and I look at Java base, can I open the diagrams, show diagram? Okay, this is huge actually. Okay, package. Oh, this is so huge. Where is it? I want package java.base, package JDK. Oh, it's lagging my computer. Change scope to no. Okay, I don't know if it's okay. But come on, Java base, Java, lang. I just want to find object, man. Sorry, it's taking me a second. It's just I want to find a good place. So this one, diagrams. Oh, okay, this is a huge ass diagram. Hopefully you guys can see it, but if I zoom in, can I zoom in? Oh, come on, please. Zoom in. Okay. Zoom in, and I zoom in, and I zoom in once again, and maybe I'll make this full screen. Okay, so you can see here, in this massive, massive graph, every object in Java comes from object, and it's like a big tree, and this big tree works all the way down to very specific objects like string builders and abstract string builders. It's so much, right? It looks like a ton, but this is the entire language of Java. And you can see there's thousands of things in Java. So many different items. There's objects that you probably never heard of, that I've never heard of. There's so many of these objects. And my webcam has frozen because there's that many objects. It can't even handle it. So yeah, there's an absolute ton of objects here. Let's fix the webcam. Yeah. Alright. Okay. We fixed the webcam. So there is this absolute insane number of objects. And all of them stem from object. So can anybody tell me, if I check if something is an instance of object, will it always return true? Yeah, exactly. Because instance of is checking if something is below the thing you're okay, how can I put this? I'll put it in Notepad. So, object A, instance of B. So A instance of B, it says, so I guess instance of means inherited in some way. Yes. So A instance of B is checking if A is above, or it's checking if A, it's checking if B is below A on the graph. That's what I mean to say. So instance of is checking if, so if I say if override is an instance of object, that would return true. Because override is below object on the graph. Does that make sense to everyone? Like, if I check if system is an instance of object, is object an instance of object? Yes, because object is like, object is itself. So obviously object will be an instance of object as well. I guess that is a base case, so it's good you're asking. Object is an instance of object. So I guess what I should be saying technically is if something is on the same spot in the graph or below in the graph, then it's an instance. And if it's above in the graph, it's not an instance. So can somebody tell me, is character data an instance of object? Character data is where my mouse is. Okay, awesome. Now, is object an instance of character data? No, exactly. Now, is character, down here we have character data 82. It's down here below character data. Is that an instance of object, and is that an instance of character data? Yes and yes, exactly. But is, let's say, is runnable an instance of system? less confidence there in your answers, and that makes sense because it is below, but it's not an instance because there's no line connecting them. So when you read this graph, if there's a line connecting it, that means it inherits from that. So it's like a tree. The higher up on the tree you are, the more likely instance of is to return true. That was a really long explanation, but I hope showing you the huge tree in Java made it a little bit more clear for you. I'm sorry if that made you more confused. All I'm trying to say is that instance of checks if you are an object or an inheritor of a certain object. Now that we know that, we can kind of make our class a little bit more advanced. Let's say we want another kind of object. Let's say that we have a generator. A generator is also a tool. And a generator extends tool, yeah. And it has a use method. No, not abstract. No, I want a use method. Right? And I want to have a turn on method because you can turn a generator on. So public all right, and I go back to my main, and I say new generator. And now, what if I want to turn on the lamp in the generator? Can anybody give me an idea of how I can make it turn on the object if it's a lamp and if it's a generator? Because remember, I want to turn on the lamp and I want to turn on the generator. How do I make it turn on both in this code? Using instance of, or maybe not using instance of. Now, I know it might be hard to come up with for you guys, so I'll give you, okay, or statement. That's a great solution. Let's try it. Let's try if t instance of generator. That works, right? Power goes burr, everything's fine. Now, does that look pretty good to you guys, or are you noticing that it looks a little bit repetitive? Yeah, okay. So one of you guys at least has noticed that it's a little bit repetitive. It doesn't look like it's the ideal way to do this. And that's a great intuition if you think it looks bad. That's fine. So can anybody maybe try to think of a better solution for this problem? Maybe we can look at the graph again and we can see. Is there anything we could do maybe to move turn on up a level so we can check an instance of, but we only check one instance of? Make a turn on method in tool. But how are you going to turn on an axe? Like, you can't turn on an axe. So, like, it wouldn't make sense to have it as tool. And a lot of people are now saying interface. So those are people who maybe came to my office hours or came to one of the other tutorials. But I'll get to the interface solution in a second. We could do two different things, right? We could say, public class power tool. Oh, come on. Oh, abstract, or power tool. Power tool. And here we can add a turn on method. Oh, yeah, abstract. I forgot that. Now I can just change lamp and generator to say power tool. Okay, now I run this. Oh, I don't even need to run this. I can change this now. So now if I can say if t instance of power tool, okay, so that makes sense to everybody, right? How I changed it. Instance of is now checking if the tool here is of type power tool. So what it's doing is it's going into this graph and it's seeing, is it a power tool? If it is a power tool, it can call this method. And the power tool is what contains the turn on method. Does that make sense to everyone? What I did there? Because remember, instance of is not checking if it's a specific object. It's checking if it's below a specific object. All right. So yes, it's checking lamp is indeed below power tool, so it can turn on. Generator is indeed below power tool, so it can turn on. And axe is not below power tool, so it cannot turn on. But what if there's another function we want to add to certain items? let's say an axe can be used as a weapon. So we can say public, string attack. Right? Return that, naturally. And then I would say that a lamp could also probably be used as a weapon. But a generator, not so much. You can't even lift a generator. How are you going to use a generator as a weapon? I mean, you could electrocute somebody, but that's stupid. So this one goes, slam, slam on you. Now, does anybody have any solution that you could think of to make a function that exists? See, this function exists in axe, and it exists in lamp, but it doesn't exist in generator. So it's completely messing up our entire graph. Like, I can't possibly make an abstract class that has an attack method because these already have an abstract class that they belong to, and so does this one. So it would totally make our graph like a web. It would be like a spider web of classes. It just won't work. Does anybody have any idea what I could do about that? Or does anybody actually have any questions as to why we can't do that? I'll answer why we can't do that now because I can anticipate somebody might ask. It's that Java only lets you inherit from one abstract class or one class. So one guy is saying interface. He's been saying interface the whole time. Bear with me. I'm taking it slow for the class. But an interface is the solution. So the core difference between a class, an abstract class, and an interface is how abstract they are. You can think of an abstract class as a class which may or may not have abstract members. You can think of an interface as something that must be entirely abstract. And you can think of a class as something that must not be abstract at all. So classes are 0% abstract. Interfaces can be abstract, or interfaces must be abstract. Classes cannot be abstract. Abstract classes may or may not be abstract. Make sense to everyone? Interfaces, completely abstract. Classes, not at all abstract. Abstract classes, half abstract, half not abstract. Make sense? Perfect. So, since an interface is all abstract, it follows less rules than a class. If I create an interface here, and I call it weapon, and I can say public string attack, and now if I go into lamp or generator is not a weapon. If I go into axe, and I say implements a weapon, and if I go into lamp and I say implements weapon, we can look at our graph here, and we can now see that there's another thing here. There's a weapon. And notice how now I'll give you like a little bit of a quiz on it. And this is really similar to the quizzes you're going to see in class. In fact, you might get a question exactly like this on a quiz in the future. I'm not going to say you will or you won't, but you might. So, is generator an instance of weapon? No, exactly. It's not an instance of weapon because you can see there's no arrow to it from weapon, and if you go into generator, it never says implements weapon. Is tool an instance of lamp? No, of course not. So is lamp an instance of weapon? Well, yeah, a lamp is an instance of weapon because you can see there's an arrow pointing between lamp and weapon, and if we look into lamp, it says implements weapon. So it is an instance of weapon. Now a trick question you might see would be like, is weapon an instance of object? The answer to that question would be a yes, because remember when I showed you the really, really big, scary graph before? That big graph was all of Java. And what that basically told us was that all classes are instance of object. Can you implement more than one interface? Yes, you can. You can have as many interfaces as you like. That's one of the advantages of an interface. So you can have, let's say, an interface here. I'll make another one just to demonstrate. Yes, we are indeed all the children of object. I can make another interface here, and we can call it, let's say, there's weapons, there's foods. None of these are food, but I'm sure you could eat an axe. So then you could say axe extends weapon, comma food. I don't know what kind of an axe you'll be eating, but you know, some of us in Siberia are very tough, and we're able to eat axes. So now you can see that an axe is both a food and a weapon, whereas a lamp is not a food, because like, why would you eat a lamp? That would be gross. But you could obviously eat an axe. sort of makes sense to you guys? I hope. It's a stupid example, I know, but the only kind of thing I could think of was a food. So, enjoy. Yeah, and then you can see which methods... Okay, go ahead. Yes, what's up? No, they're not. They're their own separate things. And I know I said below. Well, what I maybe should have said was below with an arrow pointing to it. Below is just easier to see, like, quickly visually. But what I meant by it, I said if it's below, it's an instance of. I mean, if the arrow is connecting it like this, like see the blue arrows are connecting it like that upwards, that means it's an instance of. The green arrow also means... Sorry, yeah, can you repeat? You cannot, no. Because, like, you know, a food might not have necessarily a durability or a name or these things. You know, that's a specific quality of tool. But you can use attack on a weapon, and food has no methods. Food is just kind of useless. But you get the point, sort of, hopefully. Right? Okay, great. So if that makes sense to all of you guys, then we've basically covered this, like a lot of Java content. In fact, we've covered topics that you might not have seen in class before, including polymorphism and, well, yeah, actually just polymorphism. Inheritance as well, that's another big one. And now we've learned this, so we can actually apply it to the thing in the Sicilian. So is everybody ready to move on, or is there anybody who has any more questions? I'll be happy to elaborate in more detail about any of the things I've covered if I need to. So let me know if you have any questions. And if not, I'll move on. I'll give you guys a little bit of time to ask your questions. Are interface classes? No, interfaces are not classes. Interfaces are like, if you imagine a abstract class as the idea of something, an interface is like the idea of a particular behavior. So an abstract class could be like the idea of a tool. The abstract class encodes everything that's common between tools and then has abstract methods for the things that are not common. An interface is like defining that an object can perform a particular action. So you can have an interface that says weapon, which means you can attack with it. I hope that rule of thumb makes a bit of sense to you. It's not a hard and fast law of physics or anything, but it's a rule of thumb that states, I'll even write it in the chat because I think it's like, it might be good to have in writing. So a class, I'll not write it in the chat, I'll write it in a notepad and I'll send it to the chat. So a class is an analogy for a type of object. An abstract class is an analogy for what it means to be a member or to be a type of object. And an interface defines a behavior an object can perform. It can attack, tools have a name that acts the same, doesn't, and here you can say these 3 lines I'll send to the chat will hopefully be able to explain to you the whole 3 things in a really short amount of time. This is the footnotes of it. This is the essence of what I'm trying to tell you guys today, right here, written down in text. I'll put it formatted a little bit more nicely for you, and hopefully it makes sense to you guys. That is basically the core of the analogy. Does that make sense to everyone? All right, perfect. So let's go into the little thing we were doing here with the cartel. It's been a while since we've seen our favorite friends, the cartel. So I'll show you guys the class diagram and we can work from there. Okay, we need to define a class called agent. Agent needs to have the same functionality of client, except if the product that it's buying is illegal, it needs to report it. So how do you guys think we could go about doing this? First off, we're going to have to make agent have the same functionality as client. Does anybody have any clue how we can replicate the functionality of client, which I will put into a window over here, into the functionality of agent? How do we make them share functionality? Keep in mind that agent already extends client. Does anybody have any ideas? How do we make the constructor act the same? How do we make the by method act the same? All right, Charlotte says super, and that's exactly on the ball. So I'll go back to the graph and I'll explain to you guys what super does. So see our old graph from my analogy? If I call super.turnOn in generator, what do you think will happen? All right, I don't have any. Power tools generator method will be. Power tool turn on will be called. That's exactly right, Ali. Power tools method will be called. Because when I do super, it moves up the graph. Super is a code word for moving up the graph. Does that make sense to everybody? Super means you're following the arrow, one step. It's like a game of Monopoly or something. Super equals follow the arrows up one step. So if I say generator super dot get name, what is called? Gwyn asks, if you call generators super.turnOn, will lamp also be turned on? No, because that is an instance thing. That would be the case if it was static. So, okay, I'll say the question once again. I'll even type it in the chat for you guys. Or I'll type it on Notepad so that the people watching the recording can see. Come on. Okay, so if I call super.get name in generator, where from is the method called? There. Ali says get name will be called from tool. Can you explain why, Ali? Yeah, because the first super called power tool, so each super corresponds to one step up the graph. You call super, it moves up to power tool. You call super again, it moves up to tool. And if you call super a large number of times, eventually it'll go all the way up to object. Does that make sense to everybody? The highest you can ever go is object. You're allowed to use super as many times as you like, so here I could put super. Well, there's nothing left because I already went above object, but you get the point. And super is just moves up the graph, and you can move up the graph as many times as you like. So now, if we go back to the client.java, agent.java kind of thing, and we look at the Sicilian package, how many times do we have to move up to access a method from by? Can we change super statements? My understanding is that we couldn't. We can sometimes, we can't in other times. It really depends on your class structure. It's very hard to find a situation where you need to chain them, but theoretically, like, you could, in theory, chain supers. It's if you inherit a lot, you could get the super of the super of the super. You can do it, but you can't chain super constructor calls twice and stuff like that. Does that make sense? Like, you can chain super in certain contexts if what you inherit has a super. Most of the time, you can't get that far because you inherit from object, like, pretty soon. Like, I can't call super from client twice because client inherits from object and then object inherits from nothing. So I can't call super an object. Does that make sense? The limit of how many times you can call super is when you hit object. If you are in a subclass of a superclass that is not object, you don't have to use super to use methods of object, right? No, you don't have to use super to use methods of object, but you have to use super to call methods of object from this if you want to override them. So if I am overriding a method, like I'm overriding by, see, client has a by method, and agent has a by method. I'm overriding the by from client in agent. And because I'm overriding it, the only way I can call the by method in client is by using super. Does that make sense? Perfect. Okay. So looking at this graph, if I want to access the by method of client from agent, what do I have to do? again, I'm trying to override by. So I'm an agent. I want to override this method. I want to override by this method from client in agent. So I'm in the class agent. I want to override by. How can I call this method when I'm in the subclass? Using super. Okay, yeah, that's right. So I can go to agent and I can say super. So we move up one step in the graph, super, dot by p. And remember, a method call with super is nothing but a method call. So we can say return super.byp. Now, the method of by will be exactly the same between agent and client. Does that make sense? Okay, perfect, because I used super, right? And I can do the same thing with a constructor. I can say super name, comma, money. And you can notice in the graph when I call that, all it's saying is that we call the super constructor of the class that it's inheriting from. Is that clear to everybody, or should I explain in more detail? Perfect. So yeah, here we can see there's a lot of methods in this class. A lot. I'll actually make it full screen so that you guys can see. So yeah, an agent overrides the by method of client. And the reason for that is an agent needs to be able to do something slightly different. All right? So what I'm going to do is I need to check if the product I'm buying, product P, is illegal. How can I check if the product I'm buying, that's a product, is illegal? How can I check that? Gwyn says instance of. And Gwyn is onto something. See, I can say, if this product is an instance of illegal, it's illegal, right? Because you can use it to commit a crime. Because illegal provides the commit crime method. So that's a great way to check for illegality. Alexander suggests we can use the is legal method, which exists in product. But now this comes to a question of, can we trust our software? So can we trust the cartel's software to accurately report if something is legal? Like, the reason I use a cartel as an example is this cartel has an incentive to not necessarily be truthful in things that they declare. So when they put a product in their database, they're probably not going to say it's illegal, right? Like, they can have an is illegal field in their database. In real life, there is, like, you know, when you go through customs and you declare what you have, you literally are declaring if what you have is legal or not, right? But usually they want to check beyond what you've declared in customs. That's why we have the whole TSA and everything. It's because you're checking beyond what's declared because you don't trust the person declaring it. Similarly, I don't know if we can trust how the mafia is declaring their products. We could try. We could certainly say, say here, if p dot... No, is legal is not private. I'm just saying that we might not be able to trust its output. Like, we might not be able to trust the result of this method. If p is legal, let's just say p dot get supplier dot report this. That's how I report things, right? So we can say if it's not legal, we report it. Let's try it. My name is Johnny, and I am starting with a lot of money, and I am a cop. So if I buy something, it's declared as legal, but it's secretly illegal. The reason for this is that nowhere in our graph does it say that is legal is forced to be true if it inherits illegal, right? Like, is legal is only a method. Nobody is saying that it definitely will return true if it's illegal. It's just saying that that's what it's declared as. So we should probably check if it's an instance of illegal, because what we really care about is, does it have the commit crime method? Like, we want to check if the commit crime method exists. Therefore, what we should do is we should check if it inherits from illegal. So does anybody have any idea how we can check if a product is an inheritor of illegal? Could you use instance of? Exactly. You can do instance of. So if we go back to our agent.java, we can say if p is illegal or p instance of illegal dot report this. So now, if I rerun that and I try to as agent 007, I start with a lot of money and I can be a cop. I will buy. And now right away it glitches because it says like I've broken the program. The point of breaking the program here is that I want to break the program. I'm saying report basically breaks the program. Like I designed this code so that report makes all the fields null and destroys the software because it basically destroys the cartel. That was like the analogy of it. And you see it worked because now that P was an instance of illegal, it checked if the product P inherited from illegal. That returned true. And when I report, if I go into the report method, it just makes everything into a null. If I wanted to not throw an error, I could say reported. And I can run this again just so it doesn't crash on you guys. By reported. See, it reported it because it was inherited from illegal. So it was declared as legal. It was illegal. It inherited from it. Makes sense to everyone? Hopefully. And that is what is the difference between a superclass and an interface? Well, an interface, again, if we go back to our analogy that I put in the notepad, it's an interface is like defining a certain behavior that this thing must implement. So an interface could be like illegal, and everything illegal, you can commit a crime using it. So that's an interface. A superclass is like, it's a class which you are extending. You're taking a class that existed before, and you are adding additional functionality onto the class. Whereas with an interface, you are defining a certain behavior, and then you are using that behavior. Does that make sense? All right, awesome. Are there any further questions? Okay, I'll probably be wrapping it up relatively quickly then today because I do have to get over to Tech Fair, lickety split. What is A in report? Oh, that's agent A, so because my report method takes an agent as argument, that's just the way I wrote it. I'm saying that to report you need to be an agent, and the way I'm checking is if you're an agent is by using that. And yes, I'll post the notepad analogy in the chat right now. And then I'll probably wrap this up because I do have to get going. But it's been a great time, and if you guys have any further questions, don't hesitate to ask me in any of the group chats or contact me by email, which I'll drop in here. There you guys go, and I'll be seeing you guys later. That was sent privately? Oopsies. Oh, both of them were sent privately. Alright, sorry, I'm not that familiar with Zoom, so I think it's set to private by default. Everyone. There's the analogy for everyone. There is my email if you have questions. You can also contact me on group chats. Otherwise, that'll be that. I'll have to be wrapping up now. Fare thee well. Thank you for coming. And good luck on the assignment and the quiz redo.